35. A wave passes through an opening in a barrier. The amount of diffraction experienced by the wave depends on the size of the opening and the wave's what? Amplitude, wavelength, velocity, or phase. We're talking about diffraction here. And diffraction is this idea that you have a boundary. I'll try to draw this boundary. And it has this opening in the middle. And there's these waves that are coming toward the boundary. And as they get closer and closer, they approach the boundary. And then, depending on the wavelength, right? Well, I just gave it away. It's number 2. This is the wavelength, right? This is lambda. And the size of the opening. If they're on roughly the same order of magnitude, then you'll get this effect called diffraction, where it passes through and the waves come out on the other side with this curvature. That's the phenomenon of diffraction. But if the wavelengths are really small relative to the size of the opening, then you really won't see this effect. Because if the opening is relatively large, then the wavelengths are so small they'll just pass through and they'll still look the way they look on the left side by the time they get to the right. And the opposite's true too. If the wavelengths are really large and the opening is really small, then you may not even notice this effect at all. So it has to be roughly the same order of magnitude for the size of the opening and the wavelength. The amplitude won't affect it. You'll see diffraction regardless of the amplitude as long as those two factors are the same. Velocity, again, same thing, and the phase doesn't come into play. 2 is the best choice.